Hi, students. We're going to talk about congruent triangles in lesson 5.2 today. So first things first, we can talk about this principle of superposition, but and you can read about it, but it's not a huge deal here. So I'm just going to kind of skip over that. If you want to read it, you can. What we're going to talk about today are congruent polygons, corresponding parts, congruent triangles, those concepts. Okay. So in two congruent polygons, all parts of one polygon are congruent to the corresponding parts or the matching parts of the other polygon. Hopefully those ideas kind of make sense since we've talked about congruent, we've talked about what a polygon is, and now we're talking corresponding parts are just matching parts here. Okay. These corresponding parts include corresponding angles and corresponding sides. So every polygon has a set of angles and a set of sides, and it's those corresponding parts are made up of angles and sides that we're talking about that are congruent. If we talk about triangles, two triangles are congruent if and only if their corresponding parts are congruent. Now, if and only if statements, remember, biconditionals mean that in this case, if we know that two triangles are congruent, okay, then we know that all parts are congruent. Okay, but we also know that in the other order, if parts of triangles are congruent, and I should be really clear here, if all parts of triangles are congruent, then the two triangles are congruent. So where we're starting with these two pieces here, the two pieces here, is we're going to start with this piece right here. If we know all parts of triangles are congruent, then we can say the two triangles are congruent. Now, very quickly, we're going to narrow that down to less stuff that we have to say, but that's where we're going to start with this. Now, this idea that if we know two triangles are congruent, then all of the parts are congruent is going to come up later on. And this is the concept that we know as CP-CTC. So we will go over this and we will need to know this, but it's good to keep this in your mind and see if one of you guys can remember this when it comes up again. But CP-CTC stands for corresponding parts of congruent triangles are congruent. That C does not stand for congruent. So if you can get that right, you're halfway there. But that's an idea that's going to come up again. So we're going to run with this idea of if all parts of triangles are congruent, then the two triangles are congruent. So we want to show that the polygons are congruent by identifying all of the congruent corresponding parts, then write a congruence statement, okay, is what we're doing in this one. So everything is marked. You can see the tick marks in here. Remember, 3 tick marks is different than 1 tick mark, okay? And the number of little arcs in the circle out here, so 2 versus 3 versus 4, is different than like the 1 little circle in there. Now, this is a place where notation is going to be a big idea. So I just remind you that you need to use proper notation. If you see a bar, you need a bar. If you don't see a bar, you don't want to have a bar. Your congruent symbol, equal with a little squiggle versus equal, are two different things. Okay, so if we're identifying all the corresponding congruent parts, angle P in this case, the one with the single marking, matches up with angle G, the one with the single marking. So we list angle G. And remember, you can put your little slash to the angle if it's easier to understand. Angle Q, we've got a double marking there. Here's my double marking down here is angle F. So we've got angle F with it. Angle R is congruent to, if I find my angle R, we've got that triple marking there. We've got a triple marking right here. So that's going to be angle E. And then angle S, we've got our quadruple is angle D. So we can match up all of those angles right there. Okay, sidewise, if we look at this, we have segment PQ. Now you can do this two ways. I can look over here and say, okay, PQ has a single mark, GF has a single mark, so I'm going to match it up with GF. Just to be clear, in PQ, congruent to whatever, I could also have written FG. Segment FG is the same thing. You do need to use capital letters and you need to use a bar over the top. Okay, segment QR, what I can do instead is if you look at QR, we've got that triple marking, and I don't think this was on purpose. Maybe it's different in your book. But just to not get these confused, what we could do is we can look up here and say, okay, if I know Q is congruent to F and R is congruent to E, then QR is congruent to FE. We put those together. So that's another way to kind of look at this. RS then, if I'm looking at that, R was E, S was D, so I'm going to say ED in this case. Then the last one, I'll go back to the diagram. SP has a double marking and DG has a double marking, so it's going to be DG as my congruent piece. Okay, you're also going to be asked for congruent statements, which really just means that I want you to tell me what figures are congruent to what. Now, they wrote polygon PQRS is congruent to polygon whatever, but you do not have to write a word in front of these. If it's 3 letters, you have to put a triangle symbol in front. But as soon as you get to 4, it's considered to be a polygon, and you can keep growing from there. So PQRS, you have to match them up in the correct order. So if I come up here, we have angle PQRS. We've already identified them. I need to list in order G, F, E, D. So it is important to list those in order. That P then should match up with the G, the Q with the F, and so on from there. Okay, so that is what my polygon is that's congruent there. Other thing that we do here in this diagram, it says triangle ABC is congruent to triangle EDC. So if we know these triangles are congruent, then we know all their pieces are congruent. So here I know angle A and angle E match up since they're both the first ones that are there. So angle A is a 90-degree angle, angle E is a 90-degree angle. I know that angle B and angle D match up. So I know that angle B and D are going to be congruent to each other. So I see the 38 there. Maybe I fill in the 38 here. And I also know that angle C and angle C are going to match up, which that's kind of a funny one, but it's because we have an angle C down here and we have an angle C up there. So those are all going to match up. What I also know is that segment AB, so the first 2 letters from here, is congruent to segment ED, the first 2 letters there. So segment AB, 3x minus 10, is congruent to or is equal distance to segment DE or ED, which is down here, which was listed as 20. So that's what I'm seeing right there is those 2 segments are equal, and I can set up an equation in order to solve there. I could keep going with this. So if you're wondering like AC matches what, because it's marked as 15. Well, if I come over here and I look at AC, it's first and last. EC is first and last. So it would match up with this EC side here, which I don't know anything about. Okay. Now let's come back to this x. I would add 10 to the other side. That would give me 3x is equal to 30. Divide by 3, we get x is equal to 10. So if I want my x value, it's 10. If I come back to the y, I'm going to look at the fact that I have a triangle here, what we talked about in 5-1. All 3 of those angles of the triangle, 38 plus 90 plus y, are equal to 180. Or I can recognize that if I have a 90-degree angle, that means that the 2 acute angles of the triangle are complementary, add up to 90. Either one of those are getting to the same thing. We're subtracting 38, and we're going to get 52. So my y in this case is going to be 52 there. Okay, so then that leads us to the third angle theorem. And the third angle theorem says that if 2 angles of one triangle are congruent to 2 angles of another, so take that part in for a second, stop there. We have 2 angles of one triangle congruent to 2 angles of the other, okay? Then the third angles of the triangles are congruent. So if you know the measure of 2 of them, you do know that the third ones are congruent to each other. And those third ones in this case is that A congruent to L in that picture, okay? So we do know that idea there. Like congruence of segments and angles, congruence of triangles is also reflexive, symmetric, and transitive. I have never seen reflexive property used for this one. Symmetric once in a while, but again, it's all about just write it the correct way the first time. If it's listed as ABC congruent to EFG and that's what you need, don't write EFG congruent to ABC. Okay. Transitive property, 1% of the time you might see this, but you do see it once in a while. If you're able to prove like ABC, or you need to prove ABC congruent to JKL, and you can prove both of them congruent to EFG, then you know that they're congruent to each other. But this does not come up a ton either. Just know that they do apply to triangles. Okay, so a kite, if we look at this one and just solving a problem, not working through kind of a proof here, just solving a problem. The kite shown is made of 2 congruent triangles. If angle BAD, so BAD over here, is equal to the measure of angle BCD, so they're giving us our congruences there in order to know what triangles are congruent, and they're telling us that those are also 45-degree angles. Okay, find the measure of angle ABD. So if I find ABD, that's this guy out here, and this one's marked as a 90, then this one is going to be 45. Now, that's something without doing the math I know, because I know I have 45, 45, 90. Some of you may have to do your 180 minus 90 minus 45, but this does come out to be 45 degrees there. Okay, so the last one is a paragraph proof, and we're going to get into a little bit more proof within this unit. And again, whether it says paragraph proof or flow proof or 2-column proof, you can do it all the same way. So I'm actually, as we go through this, going to write this out as a 2-column proof because I think most of you guys like it better that way, and it'll probably make more sense. So here it tells us that we have all of this given information. In this paragraph proof, they start with only the given information that segment WX is congruent to segment YX, and that segment WZ is congruent to segment YZ. And those are given to us. So we have those two given pieces of information that get two sides congruent, okay? And so if I look at that, I have WX, so that one's marked congruent to YX, and then I have YZ congruent to WZ, that's those ones. So by the blank property, XZ, so it tells me what I'm going to state. I'm going to state that XZ is congruent to XZ. And what this one is right here, they kind of lead you to it, and we haven't done it yet. I alluded to it earlier, but it's that if I want to say one thing's congruent to itself, this is your reflexive property. So this is when that reflexive property is going to come up. Think about that it reflects onto itself, so it's reflexive property there. So I've stated that all three sets of sides are congruent then. Okay. Then we also know in the given WXZ is congruent to YXZ. So those angles, WXZ, that's this guy up here, and YXZ. And I know that angle, let's find the other one, XZW is congruent to angle XZY. So we've got those other two that are marked in there that are congruent to each other. And that is just by the given information. I need one more set of angles listed as congruent to each other. So if I go through this, then I know that angle W, and I can just call it angle W, is congruent to angle Y. And this is going to be by the third angle theorem. So anytime that we have two angles congruent, the third one's congruent, and that's what we're using here to state that those angles are congruent to each other. I have now listed 1, 2, 3 sets of sides and 1, 2, 3 sets of angles that are congruent. So if we go back to that idea at the beginning that said that if all parts of triangles are congruent, then the triangles are congruent. That's what allows us to say this. And that's the definition of congruent triangles here that allows us to state in our last step that triangle WXZ is congruent to triangle. Make sure you do it in the correct order, but that is YXZ. And that's what we were trying to prove there. Okay, so that is an example of a proof that you can go through and you can see. And we are done for today.